Something is wrong. I think it's fine now. Yeah, it's fine. Cool, cool. So, how are you, everyone? My old computer crashed, so I am using a new one, and I have to connect it down. Let's stop here. Okay, so this week, yeah, we have two classes. This week, Wednesday and Thursday, there are no classes. So if you have any classes Wednesday or Thursday, don't go them. Don't go to those classes. And we have our second class also today. I mean, this week, which is sucks. My other section is Tuesday, Thursday. So you don't have any class on Thursday. Okay, so any question before we start? Any comments, concern, complain? Nothing yet. So in our last class, do you remember what we did in our last class? 10.5, we did that. We did rationalization. We rationalized the numerator, we rationalized the denominator, and when we did those, we had radical. So we rationalized radical. And then I talked a little bit about 10.7 immediate number. So from 10.5, I took a little detour to 10.7, but I covered only a portion of 10.7. I'm going to cover the entire 10.7 later, but before that, we are going to do 10.6. So last thing we did was about imaginary numbers. So when you have square root of any negative number, we know square root of negative number doesn't exist because you cannot find any number multiplied twice and into negative. It's impossible. So specifically, if you have a negative 1 under the square root, it becomes imaginary number I. And if you multiply two i's, they become real number negative 1. And then if you have only one number with imaginary number, you call them just imaginary number. But if you have two portions, then we call them complex number. It means same as imaginary number, but in complex number, we know that there's a real portion is there. Every imaginary number actually a complex number. But anyway, when he writes the complex number, write it out, we write the real number first and then the imaginary portion. So the format of the complex number is A plus BI. A means the real portion of the number, and BI means B, the real number, I is the imaginary portion. And we also talked about how to rationalize. We don't know how to divide radicals, so we don't know how to rationalize, how to divide complex numbers. Just like rationalizing, we also rationalize the imaginary numbers. And based on how many terms we have on the denominator, we use different methods. If we have only one term, we just multiply top and bottom by I. We multiply numerator and denominator by I, we simplify. And if you have two numbers, we use conjugate. Not two numbers, two terms. If you have two terms, then we use conjugate. So it doesn't matter which method you use. At the end, we want the final answer to be written as A plus BI format. So A is the real number, BI is the imaginary number. And I actually forgot, did this example? We did this example, right? Do you remember doing it? No? Okay. So let's start with this example. How many terms we have on the denominator? One term or two terms? One. Good. When you have one term, our life is easy. We look at what give us problem. -5. Do you have any problem with -5? Is it real or imaginary? -5. Is it real or not real? It's real. So -5 doesn't give us any problem. So what is giving us a problem in the denominator? Only the I. So we just need to get rid of the I. So we multiply both numerator and denominator by the problem I. We don't want the I on the denominator, but we are happy with the -5. -5 is real. So when you multiply by I on the denominator, we get -5 I square. And what is I square? -1. So we get -5 times -1. So what do we get? +5. And we are happy because this is real number. So our job was to do something so that you don't have to see the I on the denominator anymore. We did that, so denominator is perfect. Now for the numerator, we distribute. We get 2I plus 25. What is I times I? I squared. But every I squared turns into -1. So we get 2I plus 25 times -1, which is 2I minus 25. So we're done with rationalizing. Rationalization is over. But now you have to work with our final format. The final format says you have to write the real number first and then the imaginary number. That means we have to bring the 25 on the front and 2I on the second part. So 25 has a negative symbol, negative sign. It's -25. And what's the sign we have for 2I? Plus. So it's plus 2I over the denominator 5. Now it's not wrong, but it's not correct either, because they want specifically the real number alone first and then the imaginary number. So here we have 25 on the top, no problem, but we have 5 for both the first term and the second term. So they said, well, we're not happy, separate us. So we write both numerator, -25 and +2I. We separate them, and under each one of them, we put the same denominator. And now we are happy because this thing here is A, and this thing here is B. They want specifically to see the real number A and B. So we have the real number 25/5 and the real number 2/5. They're real. But then you can do one more line, right? What is 25 divided by 5? So this becomes -5. And then 2/5, we cannot do anything, so we leave it alone. And now you're perfectly satisfied. We see the final answer they want us to write as the format. 2/5I or 2/5? It's same thing. It's a multiplication. 2/5I means 2/5 times I. And 2I/5 means 2/5 times I. Same thing. You can put I on the top or I on the side. It doesn't matter. Any question? Okay, next we have how many terms of denominator? It's 2. This is one term and this is another term. Since there are 2 terms, so we cannot use the same method as the last one. The last one, we had only problem with the I, but here, even though we have problem with the I, but we cannot use the same method because there are 2 terms. So multiplying by I doesn't help us. Do you remember which method we use now? 5 plus 2I. conjugate 5 plus 2i. So we multiply numerator and denominator by the conjugate of the denominator. Why do we use conjugate? Why don't we use the same denominator?
What it's going to be.
So what do you get when you multiply by conjugate?
5 squared.
We get difference of their denominator square. If you multiply by 5 plus 2i, you don't get that. Only if you multiply by the conjugate, you get each term square and then minus between them. So we call them difference of perfect square. If you can't remember that, no problem, use FOIL and you get the same result. But our goal here is to not to use FOIL because we want to have an easy life. So all you have to do is take your 5, square that, and always subtract, always. Take the second term 2i and square that. But since 2i is 2 terms, so 5 squared is 25, we all know that. And what is 2i whole thing squared? It's definitely not 2i squared. It's 2 squared, I squared. So it's 4i squared. This 2i turns into 4i squared. But then we have the same thing. What is I squared? -1. So you're multiplying -4 times -1. What do you get? +4. So it's 25 plus 4. Now we are happy because we don't have any denominator. So we don't have any I on the denominator. We have 29. For the numerator, what do you do? Distribute 20 plus 8i. 20 plus 8i. 20 plus 8i. See, I combine 20 and 8i together. So you have 80. 20 plus 8i. 20 plus 8i. Are we done? No. The answer is not wrong, but it's not done either. So what do we write as the final answer? Separate. 20 over 29. And then 8i over 29. That's all we have to do for dividing imaginary number. We don't know how to divide, so we use 2 methods to rationalize instead. So in the exam or in the homework or anywhere, it will not gonna tell you that rationalize the denominator. It will either tell you divide or simplify or simply just rationalize. So it doesn't matter what direction it says. Anytime you are dividing imaginary numbers, you always have to rationalize the denominator, never the numerator. Okay. For radical, we have 2 choices, either the numerator or the denominator. They will specifically tell you which one. But for imaginary number, there is no numerator. It's always the denominator. At least in this class, always the denominator. Okay? Any question? Comments? Let's do one more together and then you're going to do one example by yourself. That's fine. So how many terms do we have on the numerator, on the denominator? Rationalize. What did I just tell you? For imaginary number, you never rationalize numerator. Never. It's always denominator. Always, always, always. I rationalize denominator. It doesn't matter what the direction says. The rule is always the denominator. So how many times do you have on the denominator? 2. So do you multiply by I or do you use conjugate? What's the conjugate of the denominator? 3 plus 2i. Good job. 3 plus 2i. And now let's do the denominator first. Who can tell me what do you get on the denominator without using FOIL? Lisa, no problem. Go ahead. Whole thing square. So what do you get from there?
You get 9 minus 4 up bar, which is gonna be 9. I first gonna turn into let's pick 1. Let's go 9 times 4 times -1, then it will turn into 9.
9 plus 4. So we're done with the denominator. We're happy. Can you guess what you're going to do on the numerator? FOIL. So if you are strong in FOILing, then you can just FOIL directly. But if you're weak in FOILing, no problem. You just take each one of them and then FOIL individually. So you take 1 and you multiply 3 plus 2i. Then you take -6i and you multiply 3 plus 2i. Again, if you know how to do FOIL without doing this step, go ahead, no problem. But this step actually is helpful for the people who get confused about FOILing. Now, what do you get when you distribute the 1? You get the same thing back, 3 plus 2i. And now what do happen when you distribute the -6i? -18i minus 12i squared. What do you observe here? They're like terms. So when you combine, what do you get? 3i. Here, 2i minus 18i. Oh, this is 2i. 2i -16i is the middle term in the combination. And then what do you observe here? I squared means -1. So -12 times -1, what do you get? Plus 12. And then what do you observe on the numerator? Do you see any like terms? 3 and 12. When you combine, what do you get? 15. So 15 minus 69. What is our last step? Separate. So 15 over 13 minus 16i over 13. And with this, we're done with rationalizing, which is dividing. Any question? Any comments? Concern? Complaint? So from this section, there will be at least one dividing question in the final exam. In the exam, I'm going to tell you what will be in the exam. But in the final exam, there will be at least one rationalizing the denominator. So you try both of them. Try with your neighbors. Let me take your attendance. Actually, Julissa, Michael, Lady, Lola, Jonathan, Reina, Ali, not here yet. Denisa is out. Samantha, Nicole, Andy, Priya, Katie, Andrew, George, Mariana, Danielle, Fatimata, Azmain, Drewing, Chloe, Ethan, Kathleen, Brennan, Rahim, Shahana, excellent. Leonardo, Brian R, Brian V, Gian, Alex, Anastasia. So 1, 2, 3, 4, 4 outs. And I have one more issue. Sure, but let's find this out. It was two juries. Yeah, it's fine. So not even what this is just. It's just like a thing. Well, how did you manage in here? Y'all up here. Thank you. Yes, I was. Big friends. How are you? Stanford, I'm never success in the board. To good. And it's 6 square, I swear. Not only 6, I swear. Yeah, on the bottom. It's 6 square, I swear. For this one? The bottom, the bottom. I didn't want to make it. Before you do negative one, first you have to do the 6 square. But it's 6 square. It's a common mistake. What it is to it? But first is side, and you cannot just put 6i square, you have to put parentheses. Do you mind the second example is the difference between a real parenthesis and not a real parenthesis? I hope so this is 6 square I square. We have to put a parenthesis here.
So isn't that 6 negative last one? It's 6 square. It's like 5, 6. Give it minus 2 to distribute. No, it's like 6, 5, 1. And that is the question said. Thank you. Anytime you have more than one given to you, please, you have to consider the power. Which is 6 square plus 1. So this is 6 square, which is and actually customers of eyes for something is focus you know, it is colors on buttons. Why is your paper? You're trying to do everything mentally? But the ones on how you change don't care. Wait, the numerator has just not a chip already. I haven't received a phone on you. Remind me less of it. Which is good. Yeah. So not the how and how do you ensure that it look right? But the dynamic is correct. First of all, minus 4. The conjugate is the same two things, but the sign is different. So you cannot multiply by the same sign. The sign has to be different. And because of that, you need my transform. But yeah, how do you 9 is 9 almost correct, but sign is wrong. 15 minus 24. Fifteen minus 24. Which I we have. What's actually happens if the computer is very much where she you have to. So down you wrote is wrong. It should be parentheses. Yes. And it's not 1. 6 squares. Then it just divides by anywhere. You don't bring over the 100? Yeah, it's hard. Then you can zoom out. So it's just like that. But you're not done because you separate stuff. Oh, okay. So in the exam, make sure you box the final answer. Yeah. Right, hard. Percentage of hash. Check. So you have 2 squared 9 plus 1, which is 10. Perfect. And then 6 minus 1, 16 minus 49, plus 5 less 9. Minus 6 minus 5. Minus 3, I started to feel very good. It's one more night. Right. 117, we can give it the money. And the partner needs to do this. That's what I use. Past I can 428. Because you have double minus and negatives. You're heading to minus. Negative 6. It's not 31, it's 6. I all things square. It's 6 square and I square. It's 26 square. 6 axes. You can help do that. It's not 6, it's 61. So Which is we have these are kind of 6 times. The first thing you have to never do also actually have strong. This one's 5 2 so that's it. We have negative 18, negative 7. So you keep the negative sign, but it's we add the numbers. Yeah. It's not too high, it's negative times 8 times. And here you're 15 and you're subtracting 24. So 15 minus 2 is not 8. It's so you're subtracting here because the other times 1. So 2 different times you're subtracting. You're subtracting 15 from 24. So see how many the different million 15 and 24. And you actually put the bigger number by your formula side. So you're able to subtract these two, but it's not in negative. Big square, I square. But in big square. And your I square. Okay. We've done it all 3. Yes. 117. One 29 17 or 13 is wrong. 29 is also wrong. Here, 1 square is 91. And this is 15 and 95. How do you get to 5 on the 2? But 20 is 20. 5 times 4 is 20. And I'm seeing one tiny mistake and then I'm picturing over here. 23 or the functions. How are you doing? Can you tell me please? Really nice one. How are you doing? 50-50. That's weird. Stop asking. So why do you always start? First, so history step about no. Your goal is to have a different line but with another person. If you can find it minus the fact that on the wall. You are given a flat line, so you need to put on otherwise, when you distribute, they don't get this way. Always, whatever you have the denominator, I find C minus 3. So, if you go to the top and combine systems, which means even if minus is so we had a quite it's always a kind of different type of down movements. Everything on the bottom one, so rolling in one, how much is that fish having 9 to what? Well, I started it. Which is the chart entry name.
Okay, so since you already know the details, I'm not going to do all the details. I'm just going to do shortcuts. What do you multiply by? The first one? 5 minus 6i. Now, when you do that, we get 5 square minus 6 square I square. Because it's everything square. So we get 25. 6 square is 36. I square is -1. As a result, the sign changed into positive 36. I'm doing shortcut, okay, because you already know the details. and that gives us 29. So not 29, 61. So then you have to separate, so I'm separating anyway. Now for numerator, it is the same thing. Let me write it the first step. 3 times 5 minus 6i, and then minus 4i times 5 minus 6i. So when you do all these things, you get 15 minus 18i minus 20i, and then minus minus plus 24i squared. These are like terms, which gives you negative 38i. This 24i squared turns into negative 24. So when you subtract 15 minus 24, 24 is bigger, it has a negative sign. Our answer will have a negative sign. And then 24 minus 15 is? So that's the final answer. Common mistake, people forget to multiply by the conjugate. They multiply by the same denominator. So what's the conjugate of the second denominator? 3 minus I. So this time we have 3 squared minus I squared. 3 squared is 9, I squared is negative 1. So you get 9 plus 1, which is 10. So you do 2 times 3 minus I minus 5i times 3 minus I. So what do you get? 6 minus 2i, then minus 15i plus 5i squared. And again, we have like terms. What do we get this time from the like terms? Negative 17i. And this plus 5 turns into minus 5 because of the I squared. So combine 6 minus 5. That gives us 1. Any question? The next one, I'm not going to do anything. I'm just going to give you the answer. What's the answer for the last one? 23 over 65. 41 I over 65. Perfect. So in the final exam, remember, at least one of them will see in the final exam. And definitely in the in-class exam. I will grade, but I'm not going to make it. I didn't even see the final exam until you see it. The final exam, 20 December something. December, oh no, one day after our last class. December 14 or something.
Is that a Tuesday or?
It's written in our website on Brightspace. Yes. So our next exam will be end of October, the last week of October. And our last year class is 15, I think. In final exam will be 16, 8 a.m. in the morning. It's a Tuesday. Final exam, 2 hours, 30 questions, and you get 24 multiple choice and 6 non-multiple choice. Also, there will be 2 parts. The first part is 1 hour, 30 minutes, no calculator. And the second part is 30 minutes, with calculator 8 question. The main problem in the final exam is the time. The time is very limited. So you have to learn how to use your time wisely. Okay, now you have two choices. Either keep working with imaginary number, which is section 10.7, or do 10.6, which is solving radical equation. What do you prefer? I was thinking, since we are doing imaginary number, let's do 10.7. It's all about imaginary number. And then we can come back to 10.6. Class 10.7 is much more fun. So you already know all these details. That square root of -1 means I. Ali, you made it. I marked you absent. So I think it's late. Why? You don't care about your attendance? Attendance and quiz are 9 or 10% of your grade. I'm too tired of grading the quizzes, so I'm taking a break. Once I'm ready to grade the quizzes again, then I'll give you the quizzes again. Until then, it's a break. So imaginary number. Square root of -1 is I, and I square is -1. Now, if you have any negative number under the square root, we can break them down into two pieces. One is square root of -1 alone, and the other one is square root of the positive portion. For example, here on the right side, square root of -a is same as square root of -1 times square root of positive a. Why do you do that? Because once you take out your negative portion, you know that negative will give you something imaginary, I, and the real number will give you a real portion. For example, if you have square root of -6, -6 is -1 times +6. So you can split our square root into two pieces, -1 and +6. This -1 is not real, so it will give you I as an imaginary part. And we have no idea what is square root of 6, but we do know it's a real number, so we keep it. So we get I square root of 6 or square root of 6I. The position doesn't matter because it's multiplication. However, my MATLAB wants you to write I first and then the radicals forward because of the typing error. When people type square root of 6, they forget to move the cursor inside the radical to outside the radical. They don't do that. As a result, my MATLAB mark everything wrong. So for my MATLAB, I goes on the front, but on the paper, I goes on the right. In reality, the position doesn't matter. Now, a few fun example. Square root of -16. Let's split that first. What do you get? Square root of -1 and then +16. What is square root of -1? And what is square root of 16? 4. Now, when you have a whole number, you definitely shouldn't write I first. Even if the position doesn't matter, it just looks weird. So for whole number always comes first and then the I. Just like x, 4x. If you write x4, it's not wrong, but it looks weird. That's 4I. Any questions so far? How about the next one? We have double negative. Can you multiply these two negative? Definitely not, because one negative is inside the radical. Radical is very strong. It's like it has a very strong bodyguard. It cannot kill that bodyguard. Okay. So you can always work with outside or inside, but you cannot combine them unless you get rid of your radical. So Daniel, go ahead. What is your idea? What do you do? Mm-hmm. So outside is a multiplication, but the inside is actually the imaginary number. Mm-hmm. 9 is 3. Negative 1 is I, square root of 9 is 3. And when you put them, when you rearrange them, negative 3. Who is lost? Anybody is lost yet? Yet. Because we have a lot of other stuff to do. I can think about this too. Brennan, what can you do for C? Square root of negative 1 and square root of 7. So what do you get from square root of negative 1? I. And how about square root of negative square root of 7? We don't know what is square root of 7. So keep it. The position is not wrong, but for paper, we can write square root of 7 and then I. Using the paper, we can see that our radical symbol stops before it's getting I. But my method cannot recognize square root of 7 or square root of 7i. Can't recognize that unless you really write it correctly. Besides Daniel, who is ready for D? Ali. Mm-hmm. Negative 1 square root. 18 square root. And what happens to the negative sign? Mm-hmm. So this is negative. What is square root of negative 1? I. And now for 18. 18 is divisible by a perfect square number, right? 6 is not perfect square. You're close. 4 you cannot divide. Start with 2. Can you divide 2 by 18? So what do you get?
So it's splitting the 18 into 2. So we do 2 and
9 times 2. Why did I choose 9 times 2, not 3 times 6? Huh? Because of the 9, it's a perfect square. Our goal, anytime you simplify, you're looking for a perfect square number. Like 1 square 1, 2 square 4, 3 square 9, 4 square 16. Those are perfect square numbers. So anytime you reduce the radical, look for those numbers. So we have negative I3 square root of 2. If you drop them down, this is what you have. So how do you rewrite them nicely? Negative 3 square root of 2 and then I. On my MATLAB, it writes negative 3i square root of 2. Because it really doesn't want you to write the I after the radical. It wants you to write the I before the radical. So for my MATLAB, this is what it wants. Negative 3i square root of 2. But in reality, the position doesn't matter. As long as your I is at the end, it looks nicer on the paper. Okay. Now multiply imaginary numbers, you already know that. You already multiplied many numbers, right? When you did division, you already multiplied them. So let me just go over there real quick. 3i times negative 3i times negative 9i. What do you get? Ethan. Sorry, not Ethan. George. We get 27i square. But anytime you see anything besides I, you have to change it. What is I square? 91. So you must change the imaginary number into real number. Any power besides 1 on I doesn't cannot stay. Anything besides 1 on the power on the I, you must reduce. I square, I cube, I4, I5, I100. Anything you see, you have to reduce it down. Uh, Here, the whole semester I was keep telling you, as long as you have same radical and your radicals are positive, you're allowed to multiply them. Why did I tell you? Because of this. The radical on the square root of -2. That's -2. Is it positive or negative? Negative, right? The 14, is it positive or negative? So are you allowed to multiply -2 and -14? We cannot, because they're negative. We can only multiply positive radicals, not negative radicals. So multiplication is out of the question. It cannot do that. So how do you start them? You have to split. Square root of -1, +2. Square root of -1, +14. And now since both of them are positive, so you're allowed to multiply them this time. Because 2 is positive, 14 is positive. So what is -1 gives us another square root? I. What is this? -1 gives us another square root? Another I. And if you multiply 2 and 14, what do you get? 28. Or you don't even have to multiply. You can simply do 2 times 14. Or let's multiply because it's a simple number, 28. Now all of these are your multiplying. When you don't see any plus or minus sign, it's always multiplication. So what is I times I? I squared. And how about 28? Can you divide 28 by 1, 4, 3 square is 9, 4 square is 16, 5 square is 25. Can you divide 28 by any of these? I mean, 1 doesn't count. 4. 4 times what? 7. So you have to split that. Square root of 4, square root of 7. Anytime your radicand is divisible by a perfect square number, you must divide that. So we are dividing 28 by 4, we get 7. Now what do we get from I square? -1. What do we get from square root of 4? 2. And can you reduce 7, square root of 7? So you keep it. So when you combine all of these, what's the final result? -2 square root of 7. So you see, we started with 2 imaginary numbers, but when you multiply 2 imaginary numbers, what do you get? A real number. Anytime you multiply 2 imaginary numbers, or 4 imaginary numbers, or 6 imaginary numbers, you always get a real number back. That's the beauty of the imaginary numbers. They multiply even many times, they become real. Think about the next one. Square root of -90 over square root of -2. Who thinks he or she has a wrong idea how to approach this question? Who thinks, I mean, not right, who thinks she's definitely doing to, she or he is definitely doing the first step wrong? Anybody like that? Like you know what you're thinking is wrong. No? Jonathan, tell me your idea. What is your first idea? What do you think? How do you simplify that? What is your idea? You don't have to be perfect. You don't have to be correct. Just tell me your idea. How you are going to do, how you are going to split that? How you are going to simplify that? When you see 90, what comes in your mind? Okay. So square root of -1, square root of 9, and square root of 10. Okay. No problem. And how about the denominator? What do you see on the denominator? Good. Good approach. Not bad. And then you see they're the same exact thing. We're allowed to cancel them. Now, what do you see now? -1 cancel out. So what is left? What is square root of 9? 3. And then here's square root of 10, and here's square root of 2. You're not wrong. Perfect. Now what do you think? How? Good. So 3 square root of 2 and square root of 5, and here's square root of 2 on the denominator. Good job. So what's the answer? Perfect. You did it correctly. To be honest, I actually never thought about this process. You know what I always see in this question? This is what I see. I never actually looked at this way, which is amazing. What I always see is -90 over -2. So combine the two radical into one. They cancel out, and half of 90 is 45. So we get square root of 45. But square root of 45 is what? Square root of 9 and square root of 5. So we get 3 square root of 5. This is what I always think. I never thought about the outside of the box. Like, ooh, you break it down into smaller pieces. Wonderful. See, this is what I like to see. New ideas. So I will learn also. This is wonderful. Okay, the next, we already learned that. Blah, 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 blah. Now, addition, subtraction, multiplication works just like the normal addition, subtraction, multiplication. You add the real number, imaginary number, then imaginary number. So we have 8 minus 9i, and you're trying to subtract 6 minus 5i. What is our first step? Distribute the negative. Good. So 6 negative goes to the 6, and negative goes to the 5i. So what do you get? Plus 5i. And now you combine like terms. What like terms you see? I's. So you have minus 9i plus 5i. How many i's? Minus 9 and positive 5. So two different signs, you always have to subtract. Negative 4i. Anything else like terms? 8 minus 6. What do you get from 8 minus 6? 2. Is our format correct? The real number first and the imaginary number? Let me see it done. So this is the real number denoted by A, and this is the imaginary number denoted by BI. So A and B, they are real, only I is the imaginary number. Think about the next one. What happens here? +6. And you're adding this time, so the sign, will the sign change or sign will not change for the second polynomial? No changes. So -3 -7i. So what do you observe?
6 minus 3 is 3 minus
3 -7. So this time we don't have any like terms with the I. We only like terms with the real numbers. Any questions so far? No, interesting one. Looks bad, but actually it's not bad. Try this by yourself. Do you have more? No. I love this question, and I'm going to put one of these in the exam. I love it because it looks so bad, but actually it's not bad. George, you're already done? Cool. Who is feeling very lost? Anyone? Or at least lost, not very lost, at least feeling lost. Thank you. Okay, help me with this, Ethan. You have -36 under the square root. What is your problem here? The first problem you see. That's why I'm asking you. What is your first problem you see? You have square root of -36. So what's wrong with there? What's wrong in there? The negative sign. Good. So anytime you see a negative sign, flip that into -1 and the positive number. Problem is solved. Now what is square root of -1? It's the I. Now what is square root of 36? 6. Then we have +2 times. Same problem. So Ethan, tell me what to do right now this time. For -49. Not yet. I'm doing term by term. So combination comes later. The second term. Ethan, go ahead. Square root of -1 again, and then square root of 49, right? So what do we get from square root of -1? I. And then what do we get from square root of 49? 49. 7. What symbol goes between I and 7? Multiplication. All of these are invisible multiplication. And you're subtracting the third term. Do you see anything wrong with the third term? It's just normal 10. So you bring our normal 10 down. And now Panda says do what? Multiplication first or addition subtraction first? Multiplication. That means we have to do this multiplication first. We cannot add 6 with 2. We have to do this multiplication first, the middle multiplication first, and then you're allowed to add or subtract. So I6 gives us what? 6i plus 2 times I times 7, 14i. And this 10 is the most normal one. So it comes down. 20i minus 10. Your math is not wrong, math is correct, but you cannot stop here. You have to have the correct position. The position says the real number first. So -10 is the real. And then what symbol we have in front of 20i? Plus. So plus 20i. We have to write that in the correct format. Now, do you see, is it bad or it's not bad anymore? It's not bad, right? That's why it's my favorite, one of my favorite. Looks so bad, but actually, it's cool.
There's gonna be one that's gonna be worse. It's gonna be really, really good.
I'm not gonna give one of these with coefficient like the middle term. It will not be bad. Now, multiply, you only did multiplication, right? Multiplication comes within division. So let me skip the multiplication, but let me go over this page. Now, when you have binomial and binomial, you just do FOILing the way we did before. And now you have the same thing square. Same thing squared means you're multiplying the same thing twice. This is what power means. You're multiplying the same base twice. And then you can use FOIL. And if you know your special formula, you don't even have to use FOIL, you can simply use the formula. So if you use formula, the formula says, take the first term square plus 2 times their product. So you have 3 times 2i, that gives us 3 times 2i, which is 6i. And then you add, always add the last term square, which is 2 square I square. So you get 9 plus 12i plus 4i square. But you cannot stop. Why not? I square. That I square make this what? -4. So when you combine it, the 9, what's the result we get? 5 plus 12.
I squared
I square is -1.
You multiply that by 4, that's right.
2 square is 4, and then I times I square. So with the power means distribution. Sorry, with the power, it doesn't mean distribution, it means foiling them out. Now, what do you observe in the last example? What do you call them? Conjugate. They're the exact same two terms, with different signs. So you don't have to use FOIL. What do we get from these two pairs? Radical 5 square minus 2i squared. Today we are doing so many 2i square, right? 2i, 2i, 2i. So what is radical 5 square? Only 5. And what is 2i whole thing square? 4i squared. But then again, what is I squared? So this negative 4 will turn into positive 4. So the answer is 9. That's why we use conjugate in the rationalization, because anytime you multiply to conjugate, they always give us real number. Always. Multiplying to imaginary conjugate turns into real. With this, we are done with addition, subtraction, multiplication, division of the imaginary numbers. And now the last thing, like I said, it cannot have any power on the I that is more than 1. So last concept on 10.7 is, what if you have a power that is more than 1 on the I? How can you reduce that? You must reduce it, but how? So there are only two things you have to remember. Square root of negative 1 is I, and I square is negative 1. Besides 1 on the power on I, for everything else, you must reduce. And to reduce, after reducing at the end, it's supposed to have one of these 4 numbers. Either you're going to have a positive or a negative I as the final result, or you're going to have positive 1 or negative 1 as the final result. For anytime you reduce your power of I, there are 4 choices you have. One of them definitely has to be the answer. So how do we reduce? Depending on many people, they reduce it differently. Before I teach you the reducing method, let's see some pattern you see on the power of the I. So we know I squared is negative 1. So I cube is I squared times I, right? What is I squared? Negative 1. So if you multiply negative 1 with the I, you get negative I. See here, one of the 4 choices. This time you have negative I. Now look at I to the 4. It's I square with a square. What is I square? So if you have negative 1 square, what do you get? 1, not I. See? You're multiplying, not canceling. If it's 1/2, then you could cancel. But the 2 whole number, you cannot cancel. You cannot cancel. So see? I square is negative 1 square, means no positive 1. Now I to the 5, it means I to the 4 and I. Right? 4 plus 1 gives you 5. And from here, we already know what is I to the 4. So 1 times I, the answer is I. So this time, our answer is I. See again, one of these 4 choices. Now the last one is I squared 3 times, right? 3 times 2 is 6. So I squared 3 times. But what is I squared? So if we have negative 1 3 times, exponent rule, negative 1 with any odd power, what's the result? Negative 1. See? It doesn't matter what power you have, at the end result has to be one of these 4 choices. Now, what else you observe here? When the power is odd, what is the result? Either negative I or positive I. And when the power is even, either 1 or -1. And this is true for any odd or even power. If I is an odd power, the answer has to be either positive I or negative I. But if I has an even power, the answer has to be either +1 or -1. Let me skip this. Actually, let me do this. Let's say we have 51. Okay. It's too big, right? 51. But what is 51? Odd or even? Odd. So we know definitely our answer will be either I or negative I. One of these. Now, how do you figure out which one? We get the help of 2. Because if your I square will give you a -1, right? So I to the 50 and I to the 1 will give you I to the 51. Right? 50 and 1 gives you, this is I, my bad. 50 and 1 gives you 51. So split your 51 into 2 pieces, 50 and 1. Now 50 is even number, right? That means you have either 1 or -1 choices. So which one will get from I to the 50? Let's see. How many I square you have in I to the 50? 25 of them. That means you have -1 how many times? Add many times. What's the answer? So you get -1 from the 50 power and I from the single I. So what is our final answer? -I. So if it's even, you have only 2 choices, 1 or -1. You don't have to split that. But if it's odd, you're going to split that into even and 1 power. That 1 will give you I as a result, I. And the even number will tell you what's the sign. Is it positive sign or is the negative sign? So you divide that power by 2. So when you divide, you get 25. Then you see a -1, 25 times -1. Now let's say this 8 is actually 80. Is 80 odd or even? Even. So what the final answer will be? Either -1 or +1. 2 choices. When it's even, there are 2 choices. You have to figure out which one is correct. So what do? We get the help of the I square. How many I square you have in 84? In 80? 40. That means you have -1 40 times. I to the any even number is +1. So this is the rule. -1 to the even power turns into +1. See, why did I teach you all those exponent rules? Because you are going to use them throughout the semester. Did I tell you that in the second exam we are going to see the same rules again? I didn't tell you. I'm going to put the same 35, 36 question again with different numbers, different powers, but the same rule. End of exam 2. Because you need to remember your rules. So even though the second exam is not cumulative, but I'm definitely going to put those those questions, the exponent rules again in the second question, in the second exam. Who is lost? Anybody? Okay. So this is how I do it. Okay. But different people reduce differently. For example, some people like to just divide by 4 and then reduce 1 by 1. Some people, when you divide by 4, they memorize the rule. When you have a 3 remainder, it's -I. When you have 2 remainder, it's -1. When you have 1 remainder, it's I. When you have no remainder, it's 1. So they memorize this chart. But some people like me just divide by 2 and follow the rules. When you divide by 2, the even number means you have 31, the odd number means you have -1. And if you have odd number power, then you're going to split into 2 pieces, and then you're going to follow the same rule. So I would not recommend to memorize anything, because trust me, you can memorize everything, but during exam, you're going to mix all this up, and then you end up creating a new rule, okay? Which is wrong, definitely. So let's do a few more examples. Instead of memorizing, let's do step by step. So 22, is 22 odd or even? Even. That means what are two choices we have for the answer? 1 or -1, one of them. So what do? We see how many I square we have. 11. If you have no idea how we are figuring that out, basically what we are doing is we are dividing the power by 2. This is what you're doing. So you get 11. But why do you care about I square? Because I square is what? But basically we are looking for how many -1 we have here. How many we have, odd or even? Odd. So what is -1 to the odd power? -1. See? Oh, something a little different. Huh? Does it remind you of any exponent rule? Good job. X to the -n is 1 over x to the positive n. That's the exponent rule we are going to use here. 1 over I to the positive 25. But then 25, is it odd or even? Even. Huh? Wait, 25. Odd. So since 25 is odd, what would be the two choices for our answer? I. For odd, it's I. Either I or -I. If you have even, it's 1 or -1. If it's odd, it's definitely either I or -I. It's -I. Let's see. So we are going to split that. I don't know yet. So let's do it. So I, and how many more? 24. So we split into 2 pieces, 24 and 1. Now 24. So we have how many I square in 24? 12 of them times I. So let me just see. So 1 over. So if you have -1 12 times, what do you have? +1. So you have 1 over I. But can you stop here? You can never have I on the denominator. So what do you do? How do you get rid of the I from the denominator? You cannot just flip it. We learned it at the beginning of the class. How do you get rid of the I from the denominator? Multiply by I. Or this is what you mean by reciprocal. So we have I on the top, and what do you have on the bottom? I squared. So what is I squared? So if this is -1, what is our final answer? -I. Guess what? For guessing, there is no point in the exam. So you have to show the word. So yeah. Positive, negative doesn't matter. If it's negative, bring it down and do the same thing again. Okay, now let's do something like this. Two parts together, what do you do? Exponent rule. Which exponent rule does it remind you of? X to the M. So what do you do? M times N. So you have I to the 69. 69 is odd, right? So to split. One of them is I, and the other one is 68. Actually, let me show you, let me teach you a trick. Okay. If you divide this whole number by 2, what's the trick? Yeah. So you get 34. So when you divide, if this is even, then your answer will be 1. If this is odd, then answer will be -1. Okay. So you have I squared 34 times and I. 34 means it's even, so you'll get 1 back, not -1. So this is 1, 1, and I. So the answer is there's also another trick. Another trick. So you do the same thing. You split into one eye and then the rest is on the other eye. And then instead of dividing by 2, if you divide by 4, if you divide by 4 and you can divide evenly, then the answer is 1. If you cannot divide by evenly, the answer is -1. Specifically 4. Any number, any whole number. If it's divisible by 4 evenly, it's 1. It's not divisible by 4 evenly, it's -1. This is another trick. Let's use this trick to do the next one. What is 29? What and what? 28 and 1 I, right? So can you divide 28 by 4? Yes. So this is 1 I, which is simply I. For odd, you're going to split. That's why I split it. Okay, the next one is a combination. So 28. So 28, can you divide by 4? Yes, that means 1. If you can divide by 4, it's 1. You cannot divide by 4, it's -1. 28 is even, right? It's divisible by 4. 29 is not. It's odd. Split. So we are going to the splitting here. 34. So I to the 34 and I. And now can you divide 34 by 4? No. So what do you get from I to the 34? -1. So you have 1 times -1 plus -1 times I, which is what? Really? 1 plus -1 times I. You have to do the multiplication first. 1 minus I. Can you subtract I from 1? No. You're lost? You're okay? So we are doing 2 math together now. 28 gives us 1 and 35 gives us -I. And then you put them together, 1 minus I. And actually in the final exam, they like to give a combination. The last question for today. 60 and 70. Both are even numbers, right? Can you divide 60 by 4? You cannot. Can you do x to the 6 minus x to the 7. Can you combine them? In addition and subtraction, there is no rule. We cannot. Can you divide 60 by 4 evenly? That means the answer is positive 1. If we can divide, okay, so divide by 4 evenly, the answer is 1. Cannot divide by 4 evenly, the answer is negative 1. This is the rule, okay? Second trick rules. And then 70. Can you divide 70 by 4? No. So what's the answer for I to the 70? Negative 1. There's no I because we don't have any odd power. Both of them are even. So you have 1 plus 1, which is 2. So what I'm going to do in the exam is I'm going to give you 4 of them. So we have 4 powers. One of them will be 1, one of them will be negative 1, one of them will be I, one of them will be negative I, with some coefficients. Okay? So you're going to do everything together in one question in the exam. Did you enjoy today's class, guys? I love this section.
You're on Friday, so I guess I'll have to look at my.
Friday. I don't have my math here. I'll bring it Friday.
All right, thank you.
What's Friday? What email you sent me?
I simply didn't know that I'll bring it in today because it was last.
I didn't see that. Probably turn to the spam folder. Second.
I'm sure you don't.
So you're into the doctor? Okay. Let me see your name again. Oh,
Anything left for today? Like, do it next week.
10.7. I forgot to tell the class. 10.7.
And 10.
I'll tell them. No, you didn't do 10.6.
Obviously, only 10.7.
10.7.
We'll have the quiz for it. Or email.
Well, we do we?
Oh,
My math lab?
no.
I don't know.
Okay, I will check it.
Mhm.
I didn't understand the keywords. That's from.
I'll bring Friday. I don't have it with today. 10.5 and 10.7 do next week, Tuesday.
Okay, that's it.
Homework and quiz.
Okay, is there anything you can teach today?
Probably not. Or 10.5. But I'll extend 10.5.